So our final line will say, by the limit comparison test, our series either diverges or converges. So we need a known series to compare it to. Ignore the 1. The square root of n squared is n, times n is n squared. This series we know to be a converging p-series. Let the limit comparison test begin. That limit of our term divided by the known series term simplifies to this limit, which we can quickly see as n approaches infinity, the plus 1 becomes meaningless, so the denominator becomes n times the square root of n squared, which is n times n, which is n squared, which is 1. Now I know I used a big number logic there, where math rigor would have required that we use L'Hopital's rule. But L'Hopital's rule for this one actually is a real pain in the rear. And the College Board will accept, in the context of doing a limit comparison test, it will accept that you just show that this limit of this ratio is equal to 1, and this would be adequate communication. All right. Well, the limit of the ratio of these terms was equal to just some finite fixed value, in this case 1, and therefore, by the limit comparison test, our series does the same thing that this series does, which means it converges.